overview of satellite communication and navigation technologies. I hope it is visible to everybody. उपग्रह संचार एवं नौचालन प्रौद्योगिकियों का अवलोकन overview. So that we'll try to see some of these technologies and how they have been applied. On the screen you are seeing this picture. We are seeing these words Gagan, IRNSS, INSS satellite pictures are there, GSAT satellite pictures are there, Gaganyaan picture is there, some of the chips or ICs which you see in your radio or TV, something similar is seen on your screen, which is called NAVIC chips, and there is a logo of our NAVIC. So NAVIC is similar to something equivalent to GPS. We call it our Desai GPS. I'll come to all those details. So this is in a nutshell, I'm trying to cover all these technologies. So starting with the concept, then followed by how we are making these satellites in India, in ISRO, so that these satellites will go into the space at different orbits, and then they will serve the purpose of communication and navigation. So that is the idea of this talk. And then navigation is a new field, and some of these technology, how we apply in our flagship Gaganyaan program, which we are going to start. So already we have started the developments, but we are going to launch probably next year, early next year or by this year end. So our first flight, which will be an unmanned flight. So you would have heard about it yesterday also. But I will address it more on the context of how we are going to utilize this satellite communication and navigation in this Gaganyaan also. So that will give, it will ignite your interest also in this mission. So I'll cover this set. I will call it NavCom technologies and applications. It is navigation and communication because many of the applications utilizes both the technologies. So welcome to this fascinating world of space and especially communication and navigation. At the bottom we are seeing our headquarters picture as well as some of the place where I work, that is Space Application Center, Ahmedabad. And some of the campuses of that, we have 3 campuses. I'll come to that also. All of you know ISRO Space Vision. You would have known yesterday also. These are our pioneers, Dr. Vikram Sarabhai, who started this program from my place, that is Ahmedabad. Here there is a physical research laboratory. So the whole program, the vision started from this place in early 60s. And unfortunately, Dr. Sarabhai died very early. So then the focus shifted to Bangalore, where Professor Satish Dhawan was then director of Indian Institute of Science. So he could not move to Ahmedabad, so he requested our Prime Minister, then Srimati Indira Gandhi ji, that I cannot come to Ahmedabad, so better you bring ISRO to Bangalore. So that way our headquarters got shifted to Bangalore. And all of you know Dr. Abdul Kalam, so he was one of our great leaders in space. And these were the pioneers through which our space program has been nurtured. And the bottom you are seeing a very rare picture of Dr. Abdul Kalam with Dr. Vikram Sarabhai. This is one of the unique picture where both of them are discussing quite in detail of some of the concept. And incidentally, last year we completed the Vikram Sarabhai's Space Centenary program from 12th August 2019 to 12th August 2020. And in fact, incidentally, on 25th September 2020, Dr. Satish Dhawan's centenary program was also inaugurated. So this year we are celebrating up to 25th September 2021, the centenary program of one of our great pioneers, Dr. Satish Dhawan. This is ISRO, so I will not go much into the detail. It works directly under Prime Minister of India, Honorable Prime Minister, with the Space Commission, which is guiding all the activities of Department of Space. And at the right hand side, you are seeing the very beautiful pictures of various campuses of ISRO spread all across the country. They are worth visiting whenever you get the chance after this pandemic is over. Please do visit some of these centers and we will facilitate your visit to any of the center. Your nearby center you can visit, so you can get an idea about the work, the infrastructure, the facilities which we have set up. And now there is some changes going to affect in ISRO also. So we'll bring in more involvement of private sector into our activities. So that is what is depicted. So we have these 6 major centers, and recently we have started this Human Space Flight Center also in Bangalore. So that is added to our earlier plethora of 6 centers. So this is the 7th center added to our major center. And apart from that, we have various units and small institutes. And IIRS is one of them, which is conducting all these courses. So I thank IIRS team for organizing this course, and that will give you the benefit of learning about ISRO and its activities. So this is ISRO. And as you can see here, ISRO is almost spread all across the country. Wherever you are located, you will have something or the other nearby at your place. So you need not come all the way to Bangalore or Trivandrum or Ahmedabad for seeing the activities of ISRO. You can as well watch it at a nearby place from your hometown, your place where you are working. And wherever we are not there, say in the deep north or northeast, we are also setting up our new activities there, and we are trying to rope in various incubation centers for space activities. So that is the mandate of Government of India, that we try to bring space to your doorstep. Instead of you people coming to us, we will be coming to you. So I'll address some of those points also. So we make launch vehicles, satellites, and then various applications. So the satellite communication and navigation come under the application, because finally, if the benefits of this space technology doesn't reach you people, to the common people, then it is meaningless. So our idea, our aim, our vision, what Dr. Sarabhai envisaged was that we should apply these technologies, space technologies, and especially communication and navigation are one of the major activities or technologies which are very useful for doing the activities of a common man. So how we will do that, whether it is disaster management or finding out natural resources, environment related studies, atmosphere related studies, climate studies. Recently we heard a lot about various cyclones. In a quick succession we had 2 cyclones. So how this cyclone progression has happened, and you may be surprised to know that earlier we used to have lot many casualties during this cyclone, but this time, in fact, Yas cyclone, the last one, there was 0 casualty, and the earlier one also, Tokte, there also casualties were limited to minimal numbers. So that all is possible due to the application of the space technology. So I will dwell upon that. So disaster management and other activities, the satellite communication and satellite navigation play a major role. This is ISRO. We have almost completed 175 missions, and due to this pandemic, some of the activities were affected, but still we have been working in the background. Our Ahmedabad center is working almost all the time, except for the initial lockdown. We have at least some people always working in backside, doing various activities related to satellite communication, navigation, and other activities related to remote sensing. So till now we have 175 missions on 51 eventful years we have completed, and these launchers, PSLV, GSLV, and various types of satellite, whether it is geostationary satellites or remote sensing, polar orbiting satellites. So all these are the workhorse of ISRO's space program. And our satellite communication navigation will also be utilizing these launchers for launching the satellite and then working out the applications. So I will come in detail about all this. This is my place, Space Application Center, Ahmedabad, the birthplace of Dr. Vikram Sarabhai, from where he started all this activity. And here this big antenna which you are seeing, it is a 14-meter antenna built by a Japanese company called Nippon Electric Company. Nowadays you know it by the name NEC. All of you must have heard this name. So this was the first antenna which was set up in this country, in our India. And this is the first building which has come up. It is called the Earth Station building. So it is a ground station, because putting up a satellite is not the end of the story. Once we launch the satellite, afterwards you need this ground station to do the activities from space. So that's why the importance of ground segment is also very critical. I'll bring out those importance also. So this is the first Earth station which was built in our country. It is located in Ahmedabad. So right now we are not using this antenna or this setup, but still we have kept it as a heritage village. So whenever you get a chance to visit Ahmedabad and Space Application Center, please do come and we'll show you this antenna. It is a 14-meter diameter antenna, and this is our main campus, which is almost 90 acres. It is a very big campus. And here now at the bottom, you are seeing how we have expanded. So this was our initial campus in satellite area of Ahmedabad. And today we have another 3 campuses, as you can see here. This is the yellow one. This is the recently came up. It is called New Bhopal campus. And this is our old Bhopal campus. And then we have another education development and educational communication unit, which do social research also. Whatever activity we do related to satellite communication and navigation, whether they are reaching to the common man, what course corrections are required to be done, how we can modify it so that it benefits more for the people. So all these activity research related to that, getting feedback from the users, from the common people, from the scientists, from the actual applications, all these things is being done by this unit. So they give us a very important feedback so that based upon that we modify our program in future. And then we have a very good exhibition center, Vikram Sarabhai Space Exhibition. It is worth visiting, and whatever I am going to show you today, all these details are available in this space exhibition. And now we have started in view of this pandemic, last almost 1.5 years, we are conducting various online exhibition shows or webinars or seminars also. So if your school is interested, please do approach us, and we'll conduct a specific program for your school students also, or even teachers also. So that is the idea behind starting this online series also. And this right hand side, you're seeing this building, again another big antenna, and this building is located in Delhi, New Delhi. It is almost nearer to our Honorable Prime Minister's office. So it is called Delhi Earth Station. Although it is located in Delhi, it belongs to our Ahmedabad center, and it has again a heritage value. Like this antenna also has a very big heritage. The heritage is that during the late 70s and early 80s, our Honorable Prime Minister used to go to this place and address the whole country, which was not possible. See, nowadays sitting at your home, you can address the whole country. Our Prime Minister sitting at his office or at his home, he can now address the whole country anytime. But that was not the case in 70s and 80s. So that time, this was the place where he or she used to come to this place. Mostly Indira Gandhi ji used to come to this place and address the whole country from this place. So that's why this place also has a very good heritage value. Now we are starting a vendor complex, so it is like a very good corporate type of building here, where we will invite various private vendors who will come and do the work for ISRO. So this is in nutshell is our campus. We do various activities related to payloads and applications. And why I'm showing this is that these are the activities. We not only make communication and navigation satellites, so payloads for that, because satellite is a common structure, as all of you would have known by now. So in this satellite, the heart of the satellite or the brain of the satellite is the payload which we put inside the satellite. So Ahmedabad or the Space Application Center is a place from where we build this payload or sensors. So they work like the heart or brain of the satellite, and they carry out the different applications. So once the satellite is launched, as I mentioned, using the ground station, we try to collect the data and then apply it for various applications. So today we'll be discussing communication, navigation, and its applications. So how we build this payload and then its applications for various activities. And as you can see, this center has a unique value because it is a multidisciplinary center. Unlike our other centers of ISRO at Trivandrum or Bangalore or other places, this Ahmedabad center has a unique quality. The quality is what you can see, the manpower which is distributed across all the branches. You see, you find an electronics engineer also, a mechanical engineer also, a computer scientist also, and a geoscientist also. A science teacher like you also can, if he has a master's degree or PhD degree, he can come and join ISRO and work for geoscience or biological science or physical science or chemical science. So all these activities happen at our place here in Ahmedabad because we do a lot of application, as this title suggests. So a lot of application means we have agriculturist also, horticulturist also, and doing various biological, marine, oceanographic, meteorology, all type of applications, geological applications. So that will need people of different varieties or different skills. So that is the unique strength of this particular center, that we have hardcore technologists like me who have done is engineering in electronics or mechanical or computer engineering. But at the same time, we need scientists who will work on the actual application. So that's why this place is a unique place, because you interact with so many different varieties of people. So like in your school, you have maths teacher, you have science teacher, you have physics teacher, you have biology teacher. Something similar is the amalgamation that we have brought about in this my center here at Space Application Center. Just briefly, Chandrayaan-2, all of you know, but why I am bringing it out, because this Chandrayaan-2, last 1.5 years, it has been orbiting in space with very good results, and it also applies lot many communication and navigation technologies, because data, once it is collected from moon, it is to be brought to the earth. So that bringing it to earth will need communication. So this is one major application of communication or satellite communication, that how you collect data from a remote place, that is remote sensing. So Chandrayaan-2 orbiter is basically a remote sensor, but from that remote place, we are bringing that data back to the earth. It is beamed to the earth. So that beaming or the sending of the data happens through the communication link. So that is the importance of satellite communication. So to give you that example so that you can understand it better, that's why I have put this particular slide, that once our orbiter is moving around the moon, which is almost 384,000 kilometers away. But from there also, I can bring that data to the earth in no time. So that is the advantage of satellite communication. And same way, navigation, how it is applied here is that this Chandrayaan-2 orbiter or the spacecraft is to be controlled in its different orbits. So it needs what we call an inertial navigation unit, as well as a different type of navigation. So that's why navigation also comes into picture when even planetary missions like Chandrayaan or Mars missions are there. This is just to give you an example so that you understand better when we explain the nuances of satellite communication and navigation. Now, you know, this is Earth atmosphere and beyond. All of you may be teaching your students about all these things, that we have this troposphere, ionosphere, and all different types of spheres. You know it better. And we work from, say, ground, that is height of 0 meter to almost 36,000 kilometers. And your atmosphere will go up to 40 to 60 kilometers. So beyond that, there is space, where there is vacuum and there is weightlessness. So we work almost not only in space, but we also work on this Earth's atmosphere also. Because initially when we do experiment related to communication or navigation, we will try to use balloons also, we'll try to use aircraft also, we'll try to, satellite is the last stage when we launch anything at the height of 400 to 800 kilometers, or the final one, that is geostationary satellite, which will go up to 36,000 kilometers. And then planetary missions, which go up to, as I said, 384,000 kilometers for a moon case, or Mars case, it will be still farther. And then future, we are planning flights to Saturn and Venus and all these other planets also. So that is called interplanetary mission. That is beyond that. But all these activities will need communication as well as navigation. So that is the importance of communication and navigation. As I said, not only for our Earth missions, but the missions which we send to Mars or Moon or Venus or Saturn, and America and Russia have sent missions to Jupiter and Saturn and Uranus also. So they have been exploring space since many years, and now China and European Union has also joined this race. And shortly India will also be joining these interplanetary activities also, where right now we have limited missions to Mars as well as Moon. But in future we'll be planning Venus mission also in near future. And that way we have our own pan-interplanetary program. But as I said, everything will need communication. But as you go further and further from Earth, this communication becomes more and more complicated. So you need to apply different techniques to do this communication. These were the pioneers. I will not go into that. You people know it much better. All these laws, Kepler laws of motion, or when initially Galileo invented these space-related activity, Newton when he said that there is gravitational force. So all these things apply when we study satellite communication and navigation. And now we'll shift to satellite communication basics. Now all of you would have heard the name of Dr. Arthur C. Clarke. He was a British scientist or a fiction writer, and you can see the knowledge or the insight what he had about communication and especially satellite communication. That during those days, almost 100 years back, he was born. And in fact, all of you must be surprised to know, although he was a Britisher, his final almost 20-25 years he spent in Sri Lanka, which is our neighboring country. So he was there. He lived his life almost in his later life in Sri Lanka only. And in fact, in 2008, when he died, he was located in Colombo, Sri Lanka. So he is the great scientist or the great science fiction writer who gave this idea that if you have 3 satellites, you can communicate from any place to any place on this earth. So that was his basic principle. And that means the 3 geostationary satellites, but that satellites have to be located at the height of 36,000 kilometers. Then only you will be able to communicate all across the world with the help of 3 satellites. So that means that if you have 1 satellite, you can cover 1/3 of the globe. So that is the basic principle on which this communication related to using satellites has evolved. And nowadays, now you have satellites in different orbits, which is called low Earth orbit, mid Earth orbit, and geostationary orbit. So, and there is something called for planetary mission, heliosynchronous orbit also. So these are the various orbits of satellites. I'm not going into detail because we concentrate more on the satellite communication. But the basic principle is that if you have 3 geostationary satellites, you can communicate all across the world. So this is how the orbits of the satellite happen. So you have polar orbit, means from North Pole to South Pole or vice versa, the satellite will be moving. And since the Earth is moving beneath that, so it will, when satellite will go from north to south or south to north. But since Earth is moving, so this way you can cover the whole globe by doing remote sensing. So mostly our remote sensing or environment satellites are located in a polar orbit. They go from north to south pole. But mostly our communication satellites, they are located in this geostationary orbit. So as Dr. Clarke mentioned, if it is located on this equator at the height of 36,000 kilometers, then it appears steady. Why 36,000? Because it will appear steady with respect to Earth movement, because it is 0.5 kilometers per second at Earth's equator. So with similar speed, satellite is also moving. So it will appear stationary with respect to any point on the Earth. And then there are other category of satellite, especially our navigation satellite, which are located in the intermediate height of around 20,000 kilometers. Although Indian satellites we have put at 36,000, I will come to that, but these satellites are at the 20,000 kilometers. So mostly GPS type of satellites, which we hear for navigation, they are located at the 20,000 kilometer orbit. So these are the different type of satellite: communication, navigation, remote sensing. Where there are also camera satellites, which are called optical remote sensing satellite. Then radar satellite, which are micro remote sensing satellite. Weather satellites, which predict cyclones and gives you information about weather. Then the satellite which we send it to Moon or Mars or such interplanetary missions. They are called interplanetary satellite or space science satellite for doing science studies. Then as far as the size of the satellite is concerned, there are nano, micro, medium or big satellites. So these are all the different categories. I will not dwell into much into that. But as you can see, and the future is what we are going ahead is a Gaganyaan module, where there will be a crew module and an orbital module. And last but not the least, India also has planned to develop its own mini space station. So like you have Space Station Alpha, which has been made by USA and some of its partners, where India is not participating in the ISS space station, but India has its own plan of making its own space station. So this is how a satellite looks like. So as I said, satellite is a structure. It contains various electronics and various mechanical elements. So like south panel, north panel, east panel, west panel, like that, which will give you the basic resources for generating power, for sustaining its life, for doing communication, all those things. But the heart or the brain inside that is our payloads. And payloads are two types, communication and navigation, as far as these activities are concerned. So this is how the satellite, so these are the basic elements of any satellite, whether it is a communication satellite or navigation satellite, or it is a remote sensing satellite. So all these satellites or the satellite which are going to Moon or Mars, all will contain more or less similar type of resources like batteries. There is a bus structure, there are sensors which will give you the information about the location of the spacecraft. So all these things are common, whether you are launching a interplanetary satellite or a communication satellite or a navigation satellite. So command and data, pointing control, communication channels, thermal control, payload control, power supply for all these elements. So everything is common that is required for any satellite. And then the payload will be sitting inside this satellite, and that will do the basic work, the work of a brain or a heart, which will be the finally utilized for any specific application. So now coming to our satellite communication, this is how we started in 1975 when our Space Application Center started working on various applications. So this was the first program. 2,400 remote rural villages were set up with the satellite instructional TV experiment. So you can imagine almost 46 years back, what was the condition of our country, India. And during those time, our team went to almost 2,400 villages all across the country and set up these TV stations. So people can come and watch TV programs. So that was the basic idea. So that is one experiment on communication. So it was called the largest mass communication experiment ever carried out in world. We didn't have satellite at that time in 1975. So we hired an American satellite called ATA-6, and that paved the way for what we are seeing today, ISRO. This was the beginning of ISRO, and you are seeing the picture of one of the eminent, another scientist of ISRO, who also worked as a director of my center, Space Application Center, Professor Yashpal. All of you must have heard his name. He was a great science communicator and a great social research scientist. So any topic you give to him, and he can explain it in such a beautiful and a simple way that everybody will understand the concept. So that is the niche, what we call the greatest hallmark of a great scientist. So that was Professor Yashpal, and he started this program in Ahmedabad, and it was located 2,400 villages all across the country. And similarly, since India wanted to develop its own satellite system, then this another experiment was done. It is called Satellite Telecommunication Experiment Project. So that is called STEP, and that was started after this site program was over. And that was a step in the direction that how India can build its own communication satellite system. So that was, and to build that system, first we have to understand how communication is being used for what application. So this program was more on application side. So it's called Satellite Telecommunication Experiment. So we used to do disaster warning system, radio networking, and transportable terminals were set up all across the country. And there was communication was happening from one place to another using satellite. So that was the precursor to this INSAT and GSAT satellite which we are building now. So this was understanding is how communication can be applied for application. So these two experiments were the major initiating steps for our communication program. And today you see you have this radio or TV broadcast direct to home. Nowadays you have your dish antenna at your home. Then you have meteorological forecast. As we saw it last week, that 2 cyclones came and we are able to predict the track of the cyclone, where cyclone has reached, where there is going to be the rainfall or the landfall. So all these details, they are being tracked by our meteorological satellite, again located at 36,000 kilometers. Then we have our regular communication channels. Whenever you go to a bank ATM, you do some transaction, but the servers are located at a central place in say Bombay or Delhi. So although your ATM is situated in your village or a city, from there it communicates, your transaction details are communicated to the main server located in Bombay or Delhi. And from there it gives the go ahead, and then only you get your money from the ATM. So all these data, transactions, details, everything is stored in the central server, and that all happens at the backbone through satellite. You will not realize that, but that VSAT connectivity is for the ATM is through the satellites. And then similarly, we have all these national stock exchange where share business happens. So all these transactions also are controlled, or communication happens through this our satellite system. So they serve as a backhaul of all these transactions. We will never realize. And nowadays, some people may argue that there is already fiber optic network everywhere in the country through our ground-based terrestrial network. So that is also being utilized. Although satellite still controls only 10% of the communication. Rest 90% happens through the terrestrial communication. So from that only you can estimate that there is a lot of scope for expansion as far as our capacity for communication is concerned. And apart from that, these communication satellites are also used for telemedicine, telehealth, and the importance of that we realize now during this pandemic, that sitting at your home, you can consult a doctor through the internet link or a satellite communication link. So again, there satellite comes very handy. Then education, especially for your children, when you are sitting at your home or in your school, and you can teach your children or the students sitting at their home. So all these things we can do tele-education. So telemedicine and tele-education, importance of that we realized during this pandemic, that how it is right now we do it through internet also, but satellite also plays a major role in providing a backup structure for all these telemedicine and tele-education. And then emergency, all of you would have known that disaster time, all your communication link, telephone lines, everything, internet, everything gets stopped. If some of you would have experienced such a disaster when floods come or earthquake comes, so everything gets stopped. No terrestrial communication will happen. So that time our satellite system, INSAT and GSAT, they come handy, because satellite are not getting affected by any earthquake or any floods or rains or anything. So they can work 24/7 anytime in space. So that's why the importance of satellite is, because they work as a backup structure during this emergency situation. So this is how the application of satellite communication. So these are the different satellites which ISRO has launched all these years. I'm not going into the detail. All of you who would have heard these terms every time: INSAT 1, INSAT 2 series, INSAT 3 series, INSAT 4 series. And nowadays we are developing our own GSAT series, because we are launching it through our own launch vehicles, GSLV and PSLV. That's why they are called now GSAT series. Earlier we used to go to French Guiana, Kourou. You must have heard this name, Kourou. Or we go to USA for launching our satellite, or to Russia. But instead of that, now we are self-dependent, and up to 4,000 kg of class of satellites we are launching from our own soil, because our launchers are capable of launching it from Sriharikota. So this is the summary of all the satellites which we have built, and they cater to various type of applications. And nowadays we have new type of satellites. So because as you would have seen, there is now a demand for different type of satellite channels, TV channels, because any person who gets some money, he will start his own channel. So that's why the demand for TV channels is very high. And each TV channel will occupy around 3 to 5 megahertz of bandwidth. Now, if you see our previous satellite, INSAT 1, 2, 3, 4 series, the one transponder or one communication channel can accommodate 36 megahertz of bandwidth. So if I need 3 to 5 megahertz for one channel, that means I can accommodate only 10 to 12 channels in one satellite transponder. But there is almost, you see in your TV, almost 1,000 or almost 1,500 channels. So that you can calculate the bandwidth requirement for such channel, and all are beaming data 24/7. So that's why the need or the bandwidth requirement has gone very high. Nowadays you hear these terms: spectrum demand or bandwidth demand, or bandwidth on demand, spectrum usage, cost of spectrum. So all these terminologies come because bandwidth has become very costly. So each hertz or megahertz of bandwidth will cost you crores of money. So to avoid all those things, we are now building what we call high throughput satellites. So satellite, instead of 36 megahertz, now they can give you bandwidth in same capacity or same resources. They will give you 200 or 250 megahertz of bandwidth. So almost 8 times higher. So I can accommodate, instead of now 10 to 12 channels, I can accommodate 100 channels in that particular area or the volume of the electronics which I put in a satellite. So that will make it more efficient. Now, as I said, putting satellite is not the end of the story. You need terminals also on ground. So you need a lot of ground segment equipments to use this satellite communication. So like that, we have set up our own communication station at even Antarctica. Now you can imagine, only 3 to 4 months you get in Antarctica for doing the work. Otherwise, almost 8-9 months, it is very cold there and almost dark. And how people will be working there and setting up the whole infrastructure, which you see here in our place in cities or villages here. So that similar Earth station, what I was showing you at Ahmedabad, something similar was set up at Antarctica by our scientists. So you can imagine that how the world has progressed now. You can go to Antarctica and within that 2-3 months you can build an Earth station also, and which will start working and communicating with satellites. So I can collect data from this Antarctica and send it to India or USA or any place. So that is the beauty of this satellite communication. So as I said, to use satellite bandwidth, you need different type of terminals. So if you need a voice communication, you need say mobile voice, then mobile type of terminals. Then you have for disaster, you have distress alert terminals. Then you have higher frequency terminals. So like that, it is not putting satellite is the end of the story. You need a lot of hardware or the electronics on ground also to meet these requirements. So this was one of the satellites which we built to support our neighboring countries also. It is called South Asia Satellite GSAT-9. So now it is working since 2017, and it is serving all our neighboring countries. And as you can see, immediately after launch on 5th May 2017, that is almost 4 years back, our Prime Minister conducted a video conference again through satellite and offered this satellite for the use for all our neighboring countries, that is Afghanistan, Bangladesh, Nepal, Bhutan, all these people, Sri Lanka, and everybody is now using this satellite as a gift from India. Now, as I said, these are the high throughput satellite, how it will look like. So instead of that 36 mega bandwidth in a single transponder, now this will support almost 200 to 250 megahertz of bandwidth. So that will give you 8 to 10 types of channels. And this is our largest satellite which we have built till now. So almost 1.5 years back, we have launched this GSAT-11 high throughput satellite, which is one of the highest satellites ever built by ISRO. It is weighing almost 4,500 kg, and it has been launched because our launcher could not launch it from Sriharikota. So we have hired this Arianespace launcher from French Guiana, Kourou. It has been launched, and now that it is covering the whole India. As you can see, all the regions, whether it is north, south, east, west, and northeast, so all regions are covered by this new concept called high throughput satellites, and that will need almost 8 Earth stations are built all across the country in 4 different corners of our country. So Ahmedabad, Delhi, Bangalore, and Ranchi, this Earth station have been built, and they will support the communication activities. So from any place to any place, all across the country, we utilize this GSAT-11 satellite to do communication. As I said, the communication happens in different beams. So, and this is another category of satellite, which is all of you know your mobile phones, smartphones. So this is something similar to your mobile smartphones, but using satellite technology. So whenever you have network connectivity, all of you know, whenever you go from one place to another, many times you lose the network connectivity. And that is because the towers are not situated at that nearby place. So to avoid such situation, what happens is that wherever network connectivity through terrestrial link is not there, you utilize satellite communication, because satellite is always present. As we mentioned, 3 satellites if I put, it can cover the whole world. So something similar, you can utilize this concept to implement these mobile satellite services. So this is how a satellite phone will look like. It's slightly bigger than your smartphone, but whenever the communication through terrestrial mobile services is not possible, you switch over automatically to this mobile satellite services. So that is the concept on which people will be working now in future, that you have a seamless connectivity from terrestrial to satellite communication, and you will be able to operate your mobiles. And as I said, it is not only building space segment, but you need a big earth station if you want to support satellite communication. So this is how, say, nowadays for GSAT-11, what I showed you, the big satellite which we built recently, for its ground segment, we set up 8 stations and it costed us around 250 crores of rupees. So this all we are now trying to do, indigenize this whole concept under the Atmanirbhar Bharat program. And shortly we will design our own antenna as well as all electronic system which you are seeing here. And that will be all done indigenously within India. So that is the aim with which, so it contains a lot of antenna, feed systems, transmitter, receivers, and digital systems as a part of this earth station. So as I said, it is space segment is one part of the story. Ground segment is again another part. Now we move to satellite communication very quickly. So what is satellite navigation? Sorry. Navigation is how you try to locate a place in the world. Say, all of you know, on a world map, you may be teaching your students how to locate a place on a map or on a world map or an encyclopedia. So here, say, I want to locate, this is one institute, Tirubemban Institute of Information Technology. It is located in Gujarat, Gandhinagar. So if I want to locate this place, how I locate? So I will first try to find where it is located. It is in India. On the world map, it is in India. In India, it is in Gujarat. In Gujarat, it is located near Ahmedabad. Near Ahmedabad, it is located in Gandhinagar. So like that, we zero down to the exact place. When you zero down on the exact place, what you get is the location details of that particular. So latitude and longitude. So how to get this information? So that is the crux of the matter. Using satellite technology, how you try to find out location of any unknown place. So our India, it is in our mythology and all our other details, we claim that ancient India was the place where navigation has arisen. So Sanskrit word, we all know Navgati, or in Sanskrit or in Hindi we call now. So Nauka. So this now, from that now, this navigation word has come. That is what our claim is there. And this is a typical depiction of that. But basically what we are trying to find is that, like I mentioned about the satellite communication, that 3 satellites can cover the whole world. Something similar happens here also. If you have 3 satellites, then I can find out the location of any place or any vehicle or any person wherever he is moving on the earth. So how 3? Because we have to find out P, V and T. It is called position, velocity and time. So now 4th set, although 3 are sufficient, but 4th satellite is needed to improve the accuracy, and because we want to derive the timing information also. So that is the basic idea behind this navigation concept. So something similar to communication, but the concept here is that this satellite may be either located in a geosynchronous orbit, which is 36,000 kilometers, or it could be in the, if you want to cover the whole globe, if it is geosynchronous, then it has to be pointed out to a particular region. So that's why it is called regional services. And if it is on the mid-earth orbit location, that is what I mentioned, 20,000 kilometers height, then they can, since they will be moving always, because geosynchronous satellite will be always stationary. So they will look towards only one portion of the earth. So that's why there is a limitation. But if it is in a MEO orbit or a LEO orbit, then since earth is moving, they will cover the whole globe, but you need more number of satellites. So that is the trade-off between number of satellites needed and the navigation requirements of any particular country. So this is the basic concept, and India started its own program, and we have these 2 programs called Gagan, GPS aided. So here what we are doing is we are improving the accuracy of GPS satellites so that it can be utilized for navigation in the civilian aircrafts, because that was the idea of our Airport Authority of India. And then in 2016, we set up our own navigation with Indian constellation, NAVIC or IRNSS. Now, this is the concept or principle of satellite navigation. There is a location, say in India. So it's coordinate X, Y, Z. So this coordinate I can find out using one satellite. Okay. So with respect to satellites, I can know the vector and I can know the distance and I can locate them. But if I want to zero down on that, I need another satellite so that the intersection of that will give me another solution, because there are three variables. Any location, you need X, Y, Z, and T. So there are four variables, means I will need four equations. A basic mathematical formula, all of you maths teacher will know that for any variables we need to solve. So if you have two variables, you need two equations, then you will find out the solution. So same way we have now to locate any place on the earth, you need four type of information, or four variables are there, X, Y, Z, and T. So you need these three satellites. And then as I said, because timing information is also very critical, so you need a fourth satellite. So that will also aid in improving the accuracy of our estimation. So that's why this is the concept of the intersection of these four satellite locations on the earth will give you the exact location with a very required precision, accuracy, and along with the timing information. So that is the basic principle of navigation. So like communication, three satellites are bare minimum, but with four I can get the timing information. So as I said, initially GPS, all of you know, it is a very famous architecture, global positioning system. All of you know that. So it is in working since last 45 years. So, and it is being maintained by USA. So this GPS accuracy, if I want to utilize, say a plane moves from India to say USA. So during its journey from India to USA, almost 20 to 24 hours it will take. So if you want to track the path of this aircraft, so you have different type of sensors available. But if you have this Gagan system, so then you can get the exact location in aircraft cockpit. The pilot will know its exact location with respect to the Earth. So that is the importance of this GPS-aided geo-augmented navigation Gagan system. So this system has been set up because normal GPS receiver, if I use in this aircraft, it will not give me the desired accuracy. And there are many other error mechanisms are there that will distort the value of the location. So to avoid all these things, and then the other problem is that when aircraft moves from one place to another, it will pass through various countries. So it should seamlessly integrate and work with the satellites of that particular country also. So that's why this standardization has been carried out. So this is called satellite-based augmentation system. So this is again one form of navigation system. So we are augmenting GPS accuracies and its integrity in such a way that this can be utilized by pilots for doing landing and takeoff. Because normally you would have find that during winter seasons, especially in northern India, due to bad weather, or in northeast, our planes are diverted. They are not able to land in Delhi, say, or in Jammu, or in Srinagar, or in Shillong. So they are to be diverted, and they are either towards western side in Bombay or Ahmedabad, and then people are taken by road or by railway to their destination, especially during winter and when there is bad weather condition. So to avoid also thing, because if the pilot tries to land in a bad weather condition, there is the chance of accidents. So to avoid all those things, now with this type of SBAS system, we'll be able to land even during bad weather condition. Of course, during extreme bad weather condition, it is not taking worth that risk. But during normal bad weather condition, still we'll be able to land in such difficult conditions also. So that is the advantage of using this satellite-based navigation system. Now coming to our own navigation with Indian constellation, we call it our Desai GPS, our Indian GPS, and it is our Honorable Prime Minister has given its name Navik, because it has come from our Hindi or Sanskrit word Navik, now. So, and then we coined this acronym, navigation with Indian constellation, so which fits as a Hindi, Sanskrit or English acronym, Navik. So this is the Navik system where there are three elements of this Navik system. So you have space segment where you have 7 satellites, then you have ground segment. So as I said, any satellite system, it will not work standalone with only satellites. It will need a ground system. So there are not many ground stations to be set up in the whole country. So that also we have set up. And the third part is the user segment. User segment means people like you. You carry your mobile, and in mobile you have a GPS chipset. Something similar you will have now Navic chipset in your mobile. So you can use Navic to find out your location. You're going to some new place, you try to locate a restaurant or a shopping mall or a multiplex. So all these things now Navic will help you to locate the new places. You try to find out the location, as I mentioned earlier. So we are now providing two types of services. One is for common user or a civilian like we people, and the other services, which is called a secret service or encrypted services, they are meant only for our soldiers. That is for our armed forces or strategic forces. So why this requirement has come? All the whole NAVIC idea has come, or we call it IRNSS. It was earlier called IRNSS, Indian Regional Navigation Satellite System. Why it was developed? Because during Kargil War, if some of you will remember, in 1999, our soldiers faced a lot of problems in Kargil. That they were using, because everywhere GPS is there. You see, 95% of things which we utilize related to electronics, it will contain GPS chipset. So our weapons also contain GPS chipset. Our vehicles, which are used by Army or Navy or Air Force, they also contain that. Our fighter aircraft also contain GPS. Our naval carriers also contain GPS. So everywhere GPS is there. So what problem they faced was during that Kargil war, the GPS accuracy, they were finding it very poor. Instead of 5 to 10 meters, it was giving accuracies of 50 to 100 meters. So that will create a lot of problem. You fire a bomb, instead of landing up at the X place, it will land up in India itself. So that will not solve the problem, isn't it, during a war. So to avoid all such problems, Government of India decided that we should have our own system, because GPS is under control of US government or US Air Force. So to avoid also scenario, we should have a system which is under control of Indian people or Indian government. So with that idea, the whole program of IRNSS or NAVIC was set up. It's conceived in 1999. Government set up a committee, and after that, that committee gave a report that we should have our own system. So we embarked on the system, and by 2006-07 we started the work, and within 10 years, 2016, we have launched all the 7 satellites as well as the ground segment. Everything was made ready, and now it is ready for launch for use by civilians as well as our strategic. So now in the world, you will have 1, 2, 3, 4, 5, and that is the 6th one from Japan also, QZSS it is called. Although it is also a regional service like our Navy, and it is a limited services, so we have not included in this table. But if you see overall, there are these 5 major services which are available in the world, and India is one of them. So we have our own system, and as you can see, GPS is very famous. Last 45, 48 years it is working, and is under control of United States. GLONASS is from Russia. European Union, they have made a consortium, and it is called a Galileo system, and China has its own Beidou or Compass system. So we are competing with these 4 major players, and we have our own NAVIC system. Right now, it is meant only for Indian regions, while all these other 4 systems, they are not only for their own country, but it applies. I can also use GPS here in India. Same way, I can use GLONASS also in India, but NAVIC cannot be used by USA. So that is the difference between these 4 systems and our system. And the other difference is, as I was mentioning, these all systems, they are global system because they operate at the height of 20,000 kilometers. So that means satellites are always moving, while our satellites are at 36,000 kilometers. So they are stationary. So they will always look towards India. So that's why they are stationary. So it will cater to the needs of Indian region. So these are the logos of all this system. Our logo is also equally beautiful as other things. And services wise, as I mentioned, so it is covering whole Indian region as well as 1500 kilometers in and around India. So that is the aim of this navigation services of our NAVIC Indian region. So it will cover from 30 degrees south to 50 degrees north and 40 degrees to 140 degrees east longitude. And it will give 24/7 with a 99.9, because any navigation service, once you declare it operational, it has to provide almost 100% services. You cannot say today my services won't be available. Then user will be in problem. So this is how this satellite which we built for navigation, IIRS or Navig satellite, it is undergoing testing in our laboratories here at Ahmedabad as well as Bangalore. So this is just showing you a glimpse of that. And as I said, apart from satellites, we have also set up various earth stations all across the country. So they will aid in the improvement of performance of this satellite system. So basically, anywhere you are located in India, you will be able to get exact location with the help of satellites as well as this ground segment. But you will not know. As a user, you will carry only the small chip, as you are saying. So initially when we built the receivers, they were something very big like this because we wanted to test all the features of these receivers, of our system, of our navigation, Navig system, that it is working perfectly at all the places in the country or not. Because it should not happen that it works in Ahmedabad, but it doesn't work in Shillong, because then it is useless. So we have to test it thoroughly all across the country with all its features. So that's why you see different varieties of receivers which we have built. And finally, that receiver should come as one single chip. What is that chip? Here you can see in your watch or in your radio, you see a small tiny chip which comes from USA or Japan or Russia or America. But now we are building this chip in Chandigarh also. This is the chip which we have built in our Chandigarh complex. It is called at SCL, Chandigarh Semiconductor Laboratory we have in Chandigarh. And here I have showed you a block diagram, although many of you will not understand it. But what I am trying to convey is that I am an electronics engineer. I have studied for 4 years after schooling. 12, you teach students up to 12. Now after 12, we do engineering for 4 years. Now in this 4 years, whatever subject we study, starting with antenna to microprocessor or signal processor, everything which I study in these 4 years or 8 semesters, everything is applied in this, making this one small chip. So you can understand the complexity of any navigation system, that this one chip, small chip, it is costing only, if in bulk volumes, it will cost you only 10 cents. So you can imagine its cost is 7 to 10 rupees, the cost of this chip. But whatever I have studied during my whole 4 years of life in a college, in engineering college, in electronics engineering, everything is utilized to make this one chip. So from that itself, you can understand the complexity of any navigation system. And we have tested it all across the country, in east, west, south, north, all the parts of the country, and we try to measure the accuracies of our system, and we have found it. Although the specification was 20 meters, we have achieved up to 5 meters sort of accuracy. And to test all these things, we have to make antennas, we have to make receivers, we have to make chips or ASICs, we have to make simulators, and then we have made this timer display also, which gives you the timing like your normal clock timing. But the beauty of this clock timing is that it is derived from the satellite, and it will give you exact, accurate information. So always it will be rock steady. And as I was mentioning, the application of this navigation, as you can see, almost 98% of activity which you do in your daily life, everything uses GPS nowadays. So you can imagine the importance of navigation. So that's why India is developing its own Navig chips or Navig system, that you use location-based services, road transportation, agriculture, aviation, timing. So all these activities which we do, surveying of your field, finding out the area of your building or your farm field, everything is being done with the use of GPS or differential GPS. So that is now will be done with our own Navig system. So you can imagine the cost involved and the market it is going to generate. Because as I said, almost 98% of activity you see here, everything uses GPS. So same way Navig. So now how we have used it for various applications, here you can see. We have Shatabdi and Rajdhani trains. So all these trains are now being tracked in real time using our Navig, that is a navigation satellite as well as communication satellite. This is a communication satellite. So my location will be given by Navig satellite. So from that locomotive engine, it will go to this communication satellite. And from communication satellite, it will go to this earth station in Delhi. It is located in Chanakyapuri. So you can track right now these our chips and our system are installing almost 2,800 Shatabdi and Rajdhani trains and mail and express train. And shortly another 6,000 trains will be equipped with this. So total we will have now 8,800 trains of our country, all will be equipped with this satellite terminal with a NAVIC receiver. So that will be tracked continuously. So you open your internet and try to get location where is this Rajdhani train which is going from Ahmedabad to Delhi, right now where it is moving. So till now what was happening was that when it passes a particular railway station, the station master used to pick up a phone and inform the Chanakyapuri central station that the Rajdhani Express has passed Ahmedabad, or it has passed Baroda, or it has passed Godhra. Like that they will inform to the central station, and then they will update the information on internet, and that way you come to know about the location of the train. But that is the thing of the past. Nowadays in real time that information goes to Chanakyapuri Delhi station and it will automatically get updated on internet. So this is the advantage of using satellite communication and navigation technology. Same way unmanned level crossing, lot of accidents happen, all of you know that. So what will happen is that now when the train is moving and it is say 2 kilometers away from the unmanned level, this is the unmanned level crossing. So automatically this audio visual alarm will start ringing so that the people who are trying to cross the crossing, they will get stopped at that place. The person will hear this sound as well as see the visual indicator, he will not cross that particular crossing. So that is the advantage of automated unmanned level crossing system. So all unmanned level crossing will be now equipped with this satellite-based terminals so that we can stop such accident. Similarly, lot many boats, all of you know what Bombay happened, that a boat from our neighboring country entered Bombay and nobody noticed it. Terrorists came out of that and fired at the innocent people, and almost 168 people died in that accident. So to avoid all such things, what will happen is that all Indian boats will carry this water terminal we are putting in this locomotive. So there are 4 lakh boats moving in various seas around India. So all will be equipped with this terminal. So their location in sea will be continuously monitored by our NAVIC satellites, and that information will go to a Navy hub in Gurugram, and they will continuously track the movements of these ships. So any unknown ship, if it is coming, it will not be equipped with this terminal. So you will immediately come to know that there is some unidentified boat is moving around somewhere in our sea. So that will be caught, and our Coast Guard and other people, Navy, will take care of that particular boat. So this is the advantage of it. Then we have our fishermen going into the deep sea for fishing. So here you are saying, so we will give them a NAVIC receiver, so, and they will carry a mobile phone, but that mobile phone generally is useless. It will work only on the coastal part. So when they carry that mobile phone, they will get all the information from the satellite in real time in their native language, whether it is Gujarati or Malayalam or Tamil. So the fishermen will get information about cyclones, because once they go into the sea, they will remain there for 5 to 10 days. So during that time, if cyclone is going to come, we have to alert them in time so that they can return back. Something similar where they will get better fish yield. So that information also we will give them every day, evening 5 o'clock, we give them this information. Then cyclone alerts. Then if they are crossing international waters, if they are going towards Sri Lanka or going towards Pakistan waters, they will be alerted that now you are violating international borders in sea. So all this information will be now be available through satellite, and in real time it will be available on their mobile phones, and that too in the native language. So that is all the advantage of using all this for the governance. Then we have somebody wrote to our Honorable Prime Minister that many of our soldiers die at Siachen. All of you know about Siachen Glacier. There is temperature of minus 55 to minus 60 degree, such a cold temperature, and we send our soldiers there for 3 to 6 month duty. One battalion goes, and after 3 to 6 months they will return back and another one goes. But many times snowstorms come, avalanche comes, and they get buried inside that. We are not able to even locate their bodies. We are not able to bring their bodies, dead bodies also. So that is a real misery, because a person is not even we are not able to tell their family members what has happened to his body. So to avoid also scenario, somebody wrote to Prime Minister that India has now communication satellite, navigation satellite. Why not we use this technology to at least locate our soldiers whenever they move in Siachen Glacier, because it is a remote place. So that's why we are trying to evolve one technology so that the soldier can wear it on his hand. It is like a wearable unit. So that wherever they are moving in Siachen Glacier, their location will be known in Srinagar, because through satellite we'll get the location through our NAVIC satellite, and it will be communicated through our communication satellite, and that information will be continuously tracked in Srinagar also and in New Delhi also at the headquarters. So that is how we are planning the thing. The only problem here is that it is, as I said, very cold temperatures. So the battery has to last for 3 to 6 months, because there is no provision for charging the battery. Like you charge your mobile, I cannot charge the battery. That is one problem. Then the whole equipment has to work in minus 55, minus 60-degree temperature for almost 3 to 6 months. That is another challenge. Third challenge is it has to be very small in size, because soldier cannot, he has to carry his ration and other things. He cannot carry my big electronic equipment. So that's why it has to be made like a watch, a wearable unit, which he can wear it on his hand, and he can be continuously tracked. So all these things we are trying to see. Similarly, there is something called pseudo-light system. That is also part of navigation system. So wherever aircraft in remote areas, say in northeast or northern part, in Jammu or Kashmir, where there is hilly terrains are there, if we want our fighter aircrafts or small planes to land, airports are not there. There is not a runway like you have in Ahmedabad or Delhi or Bombay. You cannot have big runways. So what you do is that you set up this small system called pseudo-light navigation system, and that will use or aid in pilot in landing this small plane or fighter aircraft in that hilly terrain area also. So that is the technology which navigation is offering as a part of satellite company. So then similarly, all of you know Ola, Uber and all these things. So they operate on GPS. So now our aim is that how we can replace this GPS with our NAVIC satellite receivers. So we are making NAVIC receivers, so that will be part of AIS 140. Government has evolved that standard, and all these Ola, Uber and all the vehicle tracking system will now be based on our own navigation system. Similarly, as I said, sometimes back you would have heard Chief Minister of, say, Arunachal Pradesh, he died in a helicopter crash. And similarly, Andhra Pradesh, Rajsekhar Reddy ji, also he died in a helicopter or a small airplane crash. And we were not able to even locate where the aircraft has crashed in the jungle and where the remains are located. So to avoid also scenario, now all aircrafts and helicopters will also be fitted with a satellite communication and navigation terminal. So this NAVIC and our mobile satellite service, they'll be utilized for tracking. So whenever helicopter takes off, from that time onwards, it will be continuously tracked, so that if some crash or any mishap happens, where it has happened, exactly we'll be able to come to know. Then similarly, in Naxal-borne areas, our soldiers, all of you would have heard in Buxar or in Chhattisgarh and all this region, ambush happens of CRPF patrol party, and many of our Jawans died. To avoid also scenario due to the Naxalite ambush, so there will be a base camp setup of CRPF or CISF, and again they will carry this terminal and they will be continuously tracked using our NAVIC and mobile satellite service. So when they go out in jungle, their movement, whether in vehicle or when they are moving on foot, they will be continuously tracked, and sitting at the base camp outside the jungle or in Delhi or any headquarters also, they will know the movement of our troops, so that any Naxalite ambush happens, we will be immediately able to rush help to the soldiers which are in distress. So this is how our various satellite technology will help in solving all such problems of governance. So similarly, when we have our own launch vehicle program, so Sriharikota, from where we launch our satellites or rockets, so all these earth stations and timing stations, all are also now synchronized with our NAVIC timing. So as I said, this navigation system not only gives me location, but it also gives me information about the timing. So what is the time of the day at that particular time? So you synchronize all your computers and launch stations and launching pad, everything is synchronized with the constant, say like you have our Indian Standard Time, IST. IST itself will be linked with the NAVIC timing. So right now it is linked with, say, it is synchronized with GPS timing. So everything will be now, we have a National Physical Laboratory in New Delhi, which is called the timekeeper of our country. So they will synchronize all the clocks, timing references, everything will be with our NAVIC system. So this is how we have tested one of the system at our power station. All of you know, power system frequency should not vary beyond that 50 hertz plus minus 0.5 hertz. So if there is a deviation in that sinusoidal frequency of that power sinusoidal wave, then cascade tripping happens. So to avoid all such things, our power grid, because any wartime or any hostile situation, enemy will first attack your power stations because it will try to immobilize your power systems. So to avoid all such things, right now all are synchronized with GPS system. So the timing reference is now being switched over from GPS to NAVIC system. That is the plan of our government of India. So the moment we operationalize our NAVIC system, so also we did this testing in 5 power stations located all across the country, north, south, east, west, and northeast. We tested our NAVIC system and synchronized the power station, power grid synchronization was done with our NAVIC timing system, and you can see it is exactly matching the GPS synchronization which was happening till now. So we are now disseminating our timing information through our NTP server. So you can also synchronize your home computer or your laptop with the centralized timing of our NAVIC. So you can log on to the www.sac.gov.in and synchronize the NAVIC timing to your computer, because generally it is advisable that all your ATM, because ATM transaction, when it happens, the timing gets recorded. So any cyber security applications, any criminal fraud happens. So all these things, timing information is very critical for detecting all such frauds. So all these things will be now controlled with the timing which will be provided by our NAVIC satellite systems. So these are all the advantages of having your own reference system. And the ultimate will be that how NAVIC will come into your mobile phones, because all of you know you have GPS in your mobiles. So you use it to locate, as I said, when you go to a new place, you try to locate the location of different places, well-known places using your mobile. So something similar, government will come out with the resolution that in future, if you are in India and you are using your mobiles, then for location-based services, you should use NAVIC also. Russia and China, they have such law that if you are in Russia or in China, you have to use their own navigation system. You can use GPS, but at the same time, you have to use their national system also. So something similar, if our government also comes out with such resolution, and I'm sure it will come someday. So we are now right now working on how various our mobile manufacturers like Samsung, Xiaomi, and other people. So right now this NAVIC is available in high-end mobile system, but our aim is, or our plan is, that it comes in low-end mobile system also, so that a cheaper mobile will also contain our NAVIC system. So then people will automatically start using NAVIC also along with GPS. And for all these things, for a NAVIC satellite, what is important is that all of you might have heard this term called atomic clock. So this atomic clock is a very niche technology, as it is called. So it is one of the very important navigation technology which is required for navigation satellite. So we are developing our own atomic clock also. Till now, whatever satellite we have launched, we have used imported clocks, atomic clock, because you need a very precise timing. The timing reference should not deviate by the order of 10 raised to minus 13 or minus 14. That means 1 second in 10 raised to 13 or 10 raised to 14 seconds. So that will come in almost 1 lakh year. Your clock should deviate by only 1 second. So that much precision is required. You can imagine the requirement of this particular clock. So something similar we are building at our place here in Ahmedabad, and shortly we will start using our own clocks in our navigation center. So this is one of the prototype model of the clock, atomic clock, which we have built in our own country in India. Right now we are importing one clock cost almost cheaper one costs 3 crore or 2 crores, while the costlier one which GPS is using is almost 9 to 10 crores. So instead of that, now we will build our clocks costing around 1 to 1.5 crores. So that is the idea. And just lastly, 2 minutes I will take. Gaganyaan, all of you know, Gaganyaan also, that is going to be our own Indian space, human space flight program. So we'll be putting a crew module which will contain astronauts, minimum 1, maximum 3. They will be housed inside this crew module, as it is called. It will be supported by a satellite type of orbital module, and together it will weigh around 7 tons. It will be carried on our GSLV Mark III launch vehicle. It will go in space at the height of around 275 to 400 kilometers. It will stay there for, move around the Earth for 3 to 7 days maximum, and then it will be safely brought back to our own sea. So the idea is of this Gaganyaan, right? Because earlier I was showing you the picture of Rakesh Sharma or Sunita Williams or Kalpana Chawla. They have also gone into space, and they are all Indians. We call them proud Indians. But all of them have gone either, say, in a NASA satellite or the NASA Gaganyaan, or Rakesh Sharma has gone in a Russian spaceship. So they moved in somebody else's spaceship, or they have gone from the place from other country, say from USA or Russia. But here the idea of Gaganyaan is that we will be launching our own astronaut who will go from India in our own vehicle or in our own satellite or in our own crew module, and then they will return back also in the Indian region. So that is the aim of this Gaganyaan, and Honorable Prime Minister wants us to do. It will land anywhere in either Arabian Sea or Bay of Bengal. That is yet to be decided. But this is how the whole program has been achieved. And by this December end or early next year, we will first have an unmanned mission, because we have to test many technologies. So first we'll send a Gaganyaan which will move around the Earth for minimum 1 to maximum 3 or 4 days, and then it will come back safely on Earth. So for that we will be able to test all the technologies there. But what I was trying to convey, because this lecture was more on communication and navigation, that communication and navigation are also very important part of this Gaganyaan mission. How it is important? Because whenever you send a man or a person, a live person into space, you remain in contact with that person almost 100% of time. You cannot live like a child. We cannot leave him alone in space. So that is the basic principle of any human space flight. So to achieve that means how you don't leave a mother will not leave her child, isn't anytime away. So she will be always watching her or carrying her in his lap. So something similar. So when we launch a Gaganyaan, it is moving in space, and we are sitting here in India. So how we remain in contact? So that will be through communication system. So what we want is 100% through communication. So this Gaganyaan, when it is moving, I should be able to communicate with the astronaut who is sitting there in the Gaganyaan from India 100% of time, 24/7, by that 3 or 4 days when he is in orbit. I should be either in contact through voice or through video or through internet or email. So all the time I should be able to know that what is happening there. I should be in continuous touch. So I means in the Earth station. So that's why we have worked out this elaborate communication system. So we will be launching 2 other satellites. So it is not only Gaganyaan will be launched. Apart from that, whenever we send a man inside that, right now when unmanned mission is there, we are not sending the satellite. But these 2 satellites, they will be geostationary satellites. So what will happen is that only 30-40% of time it is in contact with the Indian landmass. Because directly we can see where Gaganyaan is moving, sitting in India. But the rest of the time it is moving, say, over Australia or USA, other part of the world. In that time, what will happen? Gaganyaan the astronaut will communicate through this geostationary satellite, because geostationary satellite is stationary. It will be always able to look towards the Gaganyaan. So he will communicate with this satellite, and this satellite in turn will communicate with our Earth station. So such 2 satellites are needed. Ideally 3 are needed, but the 2 also will be able to manage. So that way we will achieve this 100% communication. So that is the importance of this communication, that whenever we launch our Gaganyaan mission, astronaut will not be left alone even for 1 second of time. So that's why this 100% crew communication is a very important requirement. And then when he comes back, this crew module, when it lands in our seas, whether it is in Arabian Sea or in the Bay of Bengal, after that, it will be brought back to the land and the astronaut will be rehabilitated. So it is like what we are seeing in this COVID pandemic. It is not the end of the story that he has landed. He needs to be quarantined and then rehabilitated, because his mental status we don't know. When somebody has gone into space for 3 to 5 days, his whole psychology, his whole physiology, everything will change. So we need to first quarantine him and then rehabilitate him slowly so that he comes back to our social life. So all these things are part of our Gaganyaan mission. But what I was trying to convey, how navigation play a role is when it lands inside the sea, where it has landed, and from there, because our Coast Guard and Navy and all people will be active, so that they will immediately rush toward that crew module and bring it back. So this experiment we did during our space recovery experiment earlier. Last couple of years, we are doing all this recovery experiment also. So locating that module and its trajectory, from the moment it is trying to land into the sea and getting from the space, it is coming towards our country, the whole trajectory will be navigated, or it will be located using our NAVIC satellites. So they will continuously track this, our crew module, when it is landing into the sea, and then where it has landed, that all location also will get through our NAVIC receiver, and that will be relayed to our Coast Guard and Navy who are kept ready during the landing of this Gaganyaan module. So this is how navigation is going to help in this community. And now recently we did a very important communication experiment also. It is going to be the technology of the future. Till now I have been explaining you satellite communication and navigation, which is in a traditional way. But in future, what is going to happen? Because all of you have seen these cyber frauds and all that where your PIN number is hijacked by somebody and he will use it to do transaction and your money gets lost. So your PIN is very secret and it is encrypted. So that has to be preserved or protected. So future will be this quantum communication, as it is called. So I will use these photons. These light photons will be utilized to send the PIN number of any transaction which you do in ATM or through your internet and any other transaction, commercial transaction which you do, so that your money is safe. So if your PIN is protected, your money will be safe. The fraud will not happen. So that communication of that PIN will happen through this quantum communication in a light photon. The advantage of these photons is that they are all very random in nature. So nobody will be able to eavesdrop it. You will not be able to hack it or try to get information about this. So this is one experiment we did in our Space Application Center, Ahmedabad Center. So from one building to another in space, we sent that information through photons, and we were able to receive it at the receiving end and decode it also. So that is the beauty. And so future you will have now satellites which will be utilized to do this communication of this quantum communication using photons. So this is how now ISRO is helping various activity related to students, whether it is space event, space clubs, we will try to support. We will have space merchandise, space tutors we are going to appoint in near future. So we are taking government approvals for working out the whole program. And as I said, space exhibition is anyway part of our outreach activities, such webinars, what we are conducting through IIRS or through our center. So, and students are being encouraged to do internship training programs at our place. They can physically come when the pandemic is over, or online also we give guidance to various activities where you can utilize space technology. This is our exhibition. Please do visit it after the pandemic is over. It is worth seeing. You will get much more information about this. Many books are available about ISRO and all the space technologies which I mentioned. You will learn about that more. Some are written in a very simple way also. We are doing many activities, as I mentioned, using satellite communication and navigation, that is disaster management, tele-education, telemedicine, helping our farmers, bringing in clean water through remote sensing. So it gives us satisfaction, but there is a lot we can do. These are our leaders, all of you know them, so I need not elaborate much on that. But what differentiates ISRO is that we can manage with available resources. We are carrying even rocket parts on a cycle. That is how ISRO started its work. People with high integrity and of course with very good intellectual capability, we select very meritorious people and try to give them the training. And the basic is the work culture or the ethos or the ethical spirit of this people who work here, team spirit, because after all this satellite related work is a work of not an individual, it is a teamwork. If you don't have teams who work in unison and synergy, you cannot achieve. So that is the basic principle behind the success of ISRO. People are highly motivated. You will see even girls and ladies working late till night. They will come in shift duties. So all these things is the hallmark of ISRO culture. We give equal opportunities to ladies also. And any problem we face, problems will anyway come. As you would have seen during the Chandrayaan lander launch, we almost succeeded, and that last mile problem we failed. But we'll succeed next time. Chandrayaan 3 is almost getting ready, and by early next year we are sure that we are going to succeed. So this never give up attitude, that is all the features. So I request you school teachers, you try to inculcate all these ethical, moral, and as well as highly intellectual qualities into your students also, and that will help a long way in making India a better place. So thank you all. I hope I have given you enough glimpse of the satellite technology, how we can utilize it for various applications. Thank you.